So if you look at here, get a better representation here when you see actually, this is actually the strips, they actually cells in cells. So if I turn this thing again around it, so you can get some, each one of those cells, they interconnected like, where is it? Like you see it in here, which is metal strips, and then the actually module itself, this is a connection what? A series type of connections from the modules that actually you're getting, oh, they can't see. Excuse me? And they have it in the book that you can get here. Each one of them will give you a certain amount of what? A voltage across in here. And this is several of these modules to form into an array. The output in here, it would be the actually operating voltage that we have, and the current that it would flow through that, it will be what? The operating current that we have. Is that clear? So this is a 4 modules interconnected in series. For the cells in here, you probably couldn't worry that much because I doubt it very much if any of you would do any kind of modifications in the modules. In the actually cells itself, this is your main interconnection between these types of terminals that you have. Okay. So obviously one of the things that you need to consider is what? The current as well as the voltage. So if you want a certain operating voltage, you connect several of those modules what? In a series. So if you have, for example, 12 volts here, 12 volts there, 12 and 12 volts up there, the actual voltage in here is going to be what? How many volts?
48.
48 volts. 48 volts. So now you have 48 volts at what current? If each one of those modules, let's say, has a current of 8.3 amps, what would be the current? 8.3 amps. Excuse me?
You're not going to have 8.3 amps. When you connect those two leads to the inverter, that's when we're going to see the current. And from the illumination as well. You're not going to have 8.3 because of the short circuit current in 8.3 amps. You just add the voltages here in series and have the voltages brought to the inverter.
The voltage in here would be actually the actual measure voltage of the open current condition. If I take those leads and I short them together, all of them now, and measure the current in here, the short circuit current of the system under these conditions, I will measure close to the expected value that I have, taking into consideration of that, yes. The short circuit current, yes. But there is some current, and that's one of the ways I'm going to test it. I mean, if I'm going to go up in the roof and I want to test the panel, how are you going to test it? In some cases, I'll take the panel and short the things together, see if I get any current flow. Well, we're going to actually testing and so forth. Now, here's a couple of the things that you need to remember as an electrician. Only devices that have the same current output should be connected in series. Because what's going to happen is, can we do it otherwise? If this one, for example, has a certain amount of current, and this is a different, so it's just mix and match, what's going to happen here? What would be the driving point of it? So ideally, it's going to have some effect, which is going to be what? The average of all of this. You understand? If this can only produce 8 amps, and this one can only give you what? 7.5, the other one 6, and so forth. Because if they are dissimilar, what's going to happen in my actual current here? It would be different. So one of the requirements is you have to get devices what? That they have the same current output, okay? If you put these similar devices, the voltage was going to be what? The output of the voltage is going to be what? The sum of each one of them, okay, devices. And the current, it would be what? The same as it would be what? From a single device. Okay, so if you look at it for the actual curves in here, what you're going to see is that if you have the open circuit what? For 2 devices in series, this is your individual device, and you put 2 of them up here, then you see that actually your voltage is going to be double the same, okay? But however, if you put in here the similar type of devices in here, and you have 2 different, the actual what? The actual output in here, it's going to be what? A combination of what? Of both of them. So you would, if you start mix and matching up there, what's going to happen to you? You're going to get voltages that are what? That are not per design. So you're going to have to play around with them. But this is what the effect. So what happens is, what am I saying this? Is don't buy a Mitsubishi one like this and then you go get another one up there, and because they're the same size, you slap them all together, and now you say, oh gee, now what happens? If you have to do it, you have to do it, but that's what the requirement. Nothing on the code that says you cannot do that though. That you cannot mix and match. And you know, being electricians, we become very creative in a lot of things, so. Do you see the importance of that? Right? Because you're going to do it. I bet you you're going to do it, because what happens is you're going to get one panel that is broken up there. You're not going to find the exact same one. And what you're going to do is you're just going to say, well, the open circuit voltage is like this. Let me take one of them, stick it up there, get the job done. Is this clear, by the way? Is this clear? Okay. Now, cells usually they're not connected in parallel, but series string devices are, okay? If you connect things in parallel, what are you going to do? You actually maintain in what? The same type of what? A voltage, and you're increasing what? The current. So when you're taking actually devices in here, this is a parallel connection. You have the strings of what? Of modules in here connected, each one of them what? In series, and then you have another one in here connected in series, and then you have another one in here connected in series, and each one of them, each group of these what? Modules in here, or strings, they're connected into what? In parallel. So as a result, if the voltage in here, for example, is what? 48 volts, what would be the voltage across in here? 48 volts. What would be the current that is going to, if I short circuit them, each one of them? Okay? So if this amount, if it would be the current that is going through here, plus the current that's going through here, plus the current that's going through here. So if I use the basic understanding for electrical flow, the current is going to come through here, it's going to come to this point in here, it's going to say, okay, let me continue down here. This current is going to flow through here, it's going to come to this point, it's going to say, okay, let me continue down here, so it's going to be this plus this, and then the current from here is going to come through here to this particular point, so we have this, plus this, plus this, so then it's going to be up here. So what we're going to have, if I take this one and short it out, I'm going to do what? Measure the actual what? Current of the total amount of this. So if I go into troubleshooting and I expect this module in here to give me what? So much current out of it, and that something is wrong up there, what do? Well, I can do a couple things, right? I can stick my probe right on my meter, my clamp on meter here. I can measure the current here. I can measure the current here. I can measure the current here and find out what? Whether that string's what? It's working. Okay? Whether that string is working. I can also measure what? The voltages across in here to make sure that I have what? The voltage. But supposedly that this string is bad in here. And I can put my voltmeter across in here and here. What do I measure? Do I have a determination which string is bad? No, because the voltage across any point in here would be what? The same, it would be the open circuit voltage. So I really need to do a couple of things. But by putting this modules what? In series, I'm increasing the voltage. By putting the modules in parallel, I'm increasing the current. So as a result, the more power that I need is what? Is that I need a certain type of voltage, which is my operating voltage, and a maximum amount of current that I can get. How do I get a maximum amount of current? By keeping the what? The device cool and getting the proper what? Radiation on it. Go ahead, you had a question.
Is there a minimum voltage you need to see? Inverter? 48 volts. It has to be rated for.
What we said, they said the actually cell voltage, the system voltage, the maximum system operating voltage is what? Maximum system voltage that you can go into this in 600 volts in here. 600 volts, so I can put a what? String of arrays in here to get a what? Up to a certain type of voltage that I want. With the minimum voltage is going to be what? If this particular, I can get one solar panel by itself, very similar to the one that they're putting now, the telephone things on Route 80, where they put them up here, okay? And it can have a certain amount of what? Well, open circuit voltage in this panel is what? 30 volts.